Hey everyone, I know you're all fascinated by LLMs.
Those large language models.
Yeah, they're everywhere these days. And it seems like everyone wants to know how they work.
Well, how they get so good, really.
Exactly. So today we're going to take a deep dive into the training process itself.
And for that, we're looking at the research paper you submitted.
Pythia, a suite for analyzing large language models across training and scaling.
It's really a game changer, this paper, from Eleuther AI.
So tell me, what makes it so special?
Well, imagine you're trying to understand how, a complex machine works.
But you only get to see the finished product.
Right, exactly. Pythia gives us this peek behind the curtain.
Oh, I like that.
We get to see how these LLMs actually develop their ability.
Step by step.
Yeah. It's not just about the end result, it's about the whole journey.
So Pythia is as not just one LLM.
No, it's a whole suite of them.
Right.
16 to be exact.
Wow.
And they range in size from 70 million parameters all the way up to 12 billion.
That's a huge range.
It is. But here's what's really important. Every single one of those models was trained on the same data set.
The pile.
You got it.
Yeah.
The pile, and in the exact same order.
And the researchers made 154 checkpoints available.
For each model?
154 snapshots.
During training.
So we can see how each model evolves over time.
Exactly. It's like having a time-lapse video.
Of an LLM's brain developing.
You got it. Researchers can actually track how the model changes.
How it learns to perform different tasks, how it develops biases, the whole thing.
It's really an unprecedented opportunity to see what's going on inside these systems.
I mean, we've talked about the pile before, but is there anything special about it in this context?
Well, they actually used it in two ways.
Okay.
First, they trained models on the regular version, which has some duplicated data in it.
Okay.
And then they created a deduplicated version of the pile.
And trained a second set of models on that.
Precisely.
So they could see how data repetition affects the training process.
Exactly.
Why is that important?
Well, think about it. If an LLM sees the same fact over and over again.
It's more likely to memorize it.
Yeah, just by rote memorization.
But is that really understanding?
That's the question, isn't it?
Yeah.
So by comparing those two sets of models,
The ones trained on the regular pile and the deduplicated pile.
you could start to answer that question.
That's brilliant. It sounds like Pythia is setting a whole new standard for transparency in this field.
I think so. And they didn't stop there.
Oh.
The researchers actually used Pythia to conduct some fascinating case studies.
Really? I'm all ears.
Okay, great. I think you'll find these really interesting.
So these case studies, where do we start?
One of the biggest concerns with LLMs is bias.
Yeah, and we know they kind of tend to reflect and amplify the biases that are already present in the training data.
Right, like they're just soaking it all up.
All the good and the bad.
Exactly.
Yeah.
So the researchers wanted to see if they could actually mitigate this bias during the training process.
Okay, so how did they do that? Did they try to, filter out all the biased language from the training data?
Well, that's definitely one approach, but it can be tough to do consistently.
Yeah.
They decided to focus on something a little more specific.
Okay.
Pronouns.
Yeah.
They took some of the Pythia models and they modified the last 7% and 21% of the training data. And in those sections, they swapped masculine pronouns for feminine ones in certain contexts.
That's an interesting approach. It's like a subtle nudge in a different direction.
Right. And it actually worked. They found a reduction in gender bias on those targeted benchmarks.
That's amazing. And did this work better on certain models?
Yeah, the larger models actually showed a more significant reduction in bias.
So it's not just about cleaning up the data beforehand. It's also about how we shape the learning process as it's happening.
Exactly. It's a lot more nuanced, and it opens up a whole bunch of possibilities for mitigating other types of bias, too.
That's really exciting. It gives me hope that we can develop LLMs that are both really powerful and responsible.
I agree. I think this is a really promising avenue of research. Now, another case study they did focused on memorization.
Okay.
And the question was, does the order of data affect what an LLM remembers? There's this idea called iterative learning.
Where you'd think that the stuff they see later in training would be more easily remembered.
Right, like the last song you heard on the radio.
Exactly.
But what they found was that memorization in LLMs is more like a Poisson process.
A Poisson process.
Yeah, it's essentially random.
Can you explain that a little more? I'm not sure I follow.
Okay, so think of it like raindrops falling randomly on a surface.
Okay.
The order that they fall in doesn't really matter.
It's just the overall exposure.
Yeah.
Yeah.
And it's kind of similar with LLMs. It seems like they're grabbing information from that data stream in a pretty random way.
So it's not as simple as assuming they'll just memorize the last thing they saw.
Not at all. And that actually has big implications for developers.
Who are trying to control what an LLM remembers.
Exactly. Simply changing the order of the data might not be enough.
We need something more sophisticated,
We do if we want to address these issues of unintended memorization.
especially like sensitive information.
Yeah, for sure. Okay, so we've talked about bias, we've talked about memorization. What else did they uncover?
Yeah, what else did Pythia help us understand about this whole training process?
Well, there's one more case study that I think is super interesting.
Lay it on me.
It has to do with data frequency.
Data frequency. So how often a specific fact appears in the training data?
You got it.
Okay, but how does that actually affect how well an LLM learns?
Well, they tested this using arithmetic tasks and trivia questions.
Okay.
And they found something really fascinating. This frequency effect mainly showed up in the larger models,
Really?
and it actually became stronger as the training went on.
So bigger models need to see a fact more times before they can really use it effectively.
That's what it seems like, yeah. And, you know, maybe that's because those larger models have these more complex internal representations.
Right, and they need more data to solidify those connections.
It's like learning a new language. The more you immerse yourself in it, the better you're going to understand it.
That's a great analogy. So does this mean we need to rethink how we train larger models?
Potentially, yeah. It really highlights how important data quality is.
And maybe the need to think about how we structure the training data.
Like a curriculum, almost?
Yeah. This is so cool. It's like Pythia is giving us this amazing glimpse into what's actually happening inside these LLMs.
It really is. I mean, this is just the beginning.
I know. I can't believe how much we've learned just from this one paper.
And the researchers behind Pythia, they really believe this is just the tip of the iceberg.
What else could be out there? It makes you wonder what other hidden patterns we might find as we dig deeper.
And what happens is these LLMs get even bigger.
Right. I mean, what if we have models with trillions of parameters? What are we going to learn then? So much to think about. I mean, where do we even begin to unpack all of this? What are some of the key takeaways for our listeners today?
I think the biggest one is that Pythia is such a powerful tool.
Yep.
I really think it's going to completely change how we understand LLMs.
It's giving us this level of transparency we've never had before.
Yeah, exactly.
It's like we've been driving these super powerful machines without a manual, and now finally Pythia is giving us a chance to peek under the hood.
I love that analogy.
And by being able to see how these LLMs evolve over time, I mean, we're uncovering some pretty surprising things.
Yeah, about bias, about memorization, and the role of data frequency. It's really fascinating.
And all of these findings have huge implications for how we develop and train these LLMs going forward.
Oh, for sure. Pythia is going to fuel so much new research.
I can only imagine.
People are already using it to explore new ways to mitigate bias, to control memorization, and to design better training data.
I'm still stuck on that data frequency thing.
It's pretty wild, right?
It really is. It seems like there's so much more to learn there.
Absolutely. It raises so many questions about how we design these training data sets in the first place and how we can optimize them for different model sizes.
This whole deep dive has just been mind-blowing. Pythia really is a game changer.
It is.
And I can't wait to see what other discoveries it leads to.
Me neither. And to everyone listening, I really encourage you to check out the full Pythia paper.
We'll definitely include a link in the show notes.
It's such a fascinating read.
It'll give you an even deeper appreciation for just how complex this whole LLM training process really is.
It's a wild ride.
It is. And until next time, keep exploring the amazing world of LLMs.